All right, good afternoon. So my name is Anne Bertuccio, and I'm one of the leads in Google's open source programs office. And I bet like a lot of you, the last 18 months, you've been thinking about AI a lot, maybe a lot more than usual. I think in our programs office for open source, that's definitely been on the minds of us. And the reason is, I imagine you're here today at Gemma, it's an open model day, because you like openness. If we want to have a future that has open models as a part of it and open source models as a part of it, and we will talk in a second about what the difference there is, we're going to have to answer the safety question. Because I think when people talk about open models, they bring up, okay, well, how are we going to have this open technology and have responsible and safe technology in AI? And there's legitimate questions there. Some of them I think are a little bit, people are worried, they're concerned, they're more emotional, but some of them are legitimate technical questions and they are hard questions. I want us to answer those questions though, because that's really how we're going to have this open and safe future. The good news too, I think, is, technology has been here before. You think about conversations we had around open internet, around cryptography, around open source software security, which is where I've spent a good portion of my career. We had to kind of go through this cycle where we were trying to figure out how we balance open technology with the safety and security and privacy question. So to just sort of base that, I do want to talk a little bit about kind of getting all on the same page. What actually is open source? Because I think it's gotten a little confusing where people use the term to say it to mean, well, I put this on GitHub, or it's free, or you can contribute to it. Does that all sound kind of familiar? Maybe not. Some chuckles. Okay. So actually, the only thing that makes something open source is the software's license. There's nothing else. All those other things are wonderful and great and make collaboration happen. But when we say open source, we're actually only talking about the license, and it is a defined term that the license has to meet 10 requirements to be a part of that. Rather than read them all to you, I bucketed them into these three categories. It's free to use without restriction, free to modify, and free to distribute. Free to use without restriction. What that means, if something is open source, nobody can tell you what you can or can't do with it. Similarly, if I release something, I can't tell people you can only use it in this way. Please don't do that. I'm not comfortable with that. Then it's not open source. Free to modify, similarly, you can't tell someone, well, you can't edit it in this way, or you can't take my project in this other direction. I'm not comfortable with that. I don't like that. I don't support that. That's not an option in open source. We don't get control over modifications. And free to distribute and redistribute. If you make those modifications, you can just pass those around as you'd like with whatever source is necessary to make those modifications practical to somebody else without asking for anybody's permission. So was kind of a little bit of a punk anarchist as a kid, so I really like these things. These are great. This is when we want to talk about developer autonomy and, creativity and being in control of your technical journey, your destiny. This makes it happen. You think about being a little bit less philosophical and more practical about the license. So us, developers, we like to build stuff. We like to do things, right? Let's say you see something on GitHub. You've had this personal banking app in the back of your mind that you really want to build. You see a package, you're like, that would be super helpful. You are welcome to use that package for your personal banking app if it's open source. And the person who released it can't say, no, I don't believe in personal banking. You cannot use it that way. You can go build whatever you want, build whatever inspires you. They can't take it back. They can't tell you can't make the edits you need to make it useful for you. And if for some reason, let's say that person that released it, they're part of a company falls apart, it doesn't matter. You've got your own copy that they can't take away, and you can carry on as you would, building whatever, suits your needs. So these are really positive, powerful benefits. And I think they are the benefits actually that have gotten computing to where it is today. That's why people like myself who are really steeped in open source, we're so protective of this definition, because when open source starts meaning other things, it starts meaning something else, we're going to lose some of these freedoms and the foundations around them and the safeguards around them that makes this all possible. You'll notice with Gemma, when we released it, we didn't use the word open source. We called it an open model. And that was a choice that I'm just so proud of Google, actually, that we did that. Because what it means to put an open source license on AI right now it's still up in the air. There's a lot of concepts in open source licensing, things around derived works, author attribution, that we haven't figured it out for AI. So it's pretty tricky to figure out, well, how are we going to put that open source license over there? And so in the meantime, Google said, we're not going to call it something that it's not. So Gemma is an open model, not an open source model. But nonetheless, when it comes to safety, a lot of these things are still going to apply to our conversation. Because let's move the situation and think not that, we're all developers building good things in the world, doing creative things like our personal banking app. Let's think instead about somebody who's hopefully not here, some malicious actor who has, from our perspective, a bad intent. And let's apply these same principles. They're taking that package that was released. They're doing something we don't agree with. They're doing something that makes us uncomfortable. You don't have a lot of options as the person who released that. And so you think about, well, what does that mean for AI? And what does that mean for the balance we want to have of open source and open models and safe and responsible open source? And how are we going to answer this sort of philosophical call of finding the balance in those two? Again, there is good news. Computing has been here before. And so that means that there's kind of a map, there's some way signs, there's lessons that we can learn, and we can apply this to AI, because I really do want us to have this open and safe AI future. Like I was saying, a lot of my career, it's been in open source software security. And so I want to use that as an example, because open source software had to deal with kind of these same things. We went through this cycle with people feeling like, open source is insecure. And people would frame things as, I'm a little bit worried, I'm uncomfortable, I've heard it's dangerous. And so they just wouldn't use it. And then what that meant is that, they lost out on all the joys and benefits of open source. All the things that, if you're an open source enthusiast, you probably love, that person didn't experience. And as the developer community, we lost out on them as someone who probably had something to contribute and a unique perspective to bring to us. It was kind of a lose-lose. So in open source software security, what really changed the conversation was getting everyone to think in this dynamic. And this is sort of my one slide. If you don't remember anything else until, the break or happy hour or whatever, remember this part. It is the idea that open source and proprietary are different systems. It's not a versus, it's not a comparative, it's that they are different. And because they are different, they have different threat models. And I'll talk a little bit about what a threat model is in a moment, if that's not a term you're familiar with. But just imagine they have different threats. And different threats require different mitigations. And so when we want to talk about how we're going to build open source and open models that are safe and secure, we need to think about what is unique to an open model and what that uniqueness needs to have a good solution. So to be a little bit more specific, I just want to show some examples again from software security. So what happened there is after we kind of got people thinking in the mindset of different, not versus, we then had to go get a little bit more specific and make sure we were all going to be on the same page about what those threats were. So this is an example of a threat model. I don't know, are there other security people out there? Have people seen threat models before? Yay, security friend in the back. All right. Yeah, so what we kind of do in this, threat modeling is not doomsdaying. Threat modeling is being very specific about what are the scenarios that we think could happen here for abuse, for misuse, who is doing them, what kind of resources do they have? Is it an individual on their own? Are they part of a very well-funded operation? What are their intentions? What exactly are they after? And then how are they going to do those things? And once we have those hows, we have those details, then we can start actually building out solutions because we have a little bit more information than just thinking about this is a catastrophic scenario and there's nothing that can be done. So the open source community came together and we started building out threat models for open source software. And again, they're going to be different from proprietary. And this was really helpful for getting everybody just talking on the same page and thinking about things. Behind this diagram and behind this key, if you go to the website, slsa.dev, that's the Salsa website. It's a whole big project. There's a whole thing there that they only gave me 15 minutes, so I don't have time to get into it. But you'll see that behind each one of these letters, there's a huge stack of information so that the open source community, we understood who's talking about what. What really excites me in AI actually is that a lot of people are starting to make some good progress here. Just even last week, there was a really neat paper that came out of Center for Research on Foundational Models out of Stanford. It was really cool. And they started laying these things out and having these conversations. Traditional security groups like MITRE, they're building something called Atlas. And again, it's trying to chart out all these AI threats. So we are making some momentum here, making great progress, but we do need to do a little bit more. All right. So in open source, remember, different threats, different mitigations. Once we had that threat model as an open source security community, we were able to say, okay, let's talk about those hows and build what needs to be built. What we realized actually is we didn't have to build everything from scratch to make open source software more secure. There were lots of things that already existed out there that solved those little red triangles on the other diagram. So for example, how many people have two-factor authentication on their GitHub account? Okay, I see a couple hands down. That's a little concerning. During the break, actually, I think in December, they just made it a hard requirement or something. But first thing you do today, for me, if you can, go enable 2FA on your GitHub account. Security keys, tokens, whatever whatever you like to use. But so there were things that existed that we could just apply. And it's like low-hanging fruit, instant progress. Excellent. So that was good. We didn't have to build everything. But then we did find that there were a couple things that were very unique to open source. So for example, one of them was package signing and package verification. In proprietary software, there's sort of a different, there's not sort of, that's my whole, there is a different threat model. And with package signing in particular, we're talking about a different dynamic where the end user probably trusts the producer a little bit more. We know what the environments are. We know who has access to those environments. Open source isn't that way. We're developing in public. We probably have multiple maintainers who you may not know personally, have access to that build environment. And so the end user needed a way to independently verify that the package was what it said it was without trusting anybody involved. So the community came together and built this neat little idea called SigStore. And SigStore is a way to do automatic digital signing for open source packages. And it has an independent standalone verification process. It's pretty neat. And the thing that I think is really exciting about it too, is this wasn't just a bunch of security engineers who went and did something crafty with cryptography. These were people who, they cared about making sure that we were going to have open source software as part of the future and open source software that was secure. And so it's kind of one of my other messages to you all today here as well, is, you don't need to be someone who is deep in privacy engineering, security engineering, safety research to go say, I want to be a part of what we do next. I imagine you're here because you want the AI future to be open, and you probably also want it to be safe and responsible and build good things for society. So I think we can come together and make this all happen as a group. So yes, if you remember nothing else, different systems, different threat mitigations, different threat models, different mitigations. I think that's how really doing that work, putting in the effort, figuring it out, doing it together, and also having that work itself be open. So we can have these conversations, we can keep improving, we can learn from each other. And that is how we will get to the open and safe AI future.